So these were a couple of points that you need to remember in order to be a good developer and develop a good data-driven system. Welcome to a new video of our new series, Future is Data. Take any software system, be it Google, be it YouTube, be it Instagram, or be it Uber like data system. What they are doing actually, they are taking your data, they are processing your data, and after processing your data, they are storing that data. And at the end, they are again showing that data in a specific format to you, right? In Instagram, you are uploading photo, which is a kind of data, right? And they are storing this photo, they are showing this photo to your followers. In YouTube, some creators are uploading their video, so this is another data. They are storing that video in the backend database or maybe S3, and then it is showing to others, right? So this is also data related. Take another example, let's say Uber. Uber is taking some of your data that you want to go from this point to this point, taking some other data like driver details and everything, and they are matching them and showing you the data that this driver is in this location, this driver is in this location. So every system you can think of is a data system. So when as a software engineer you are going to build a data system, it's your responsibility to keep in mind all these 3 points to make the system user friendly. Reliability, scalability and maintainability are like 3 pillars of a tripod. Each leg represents a critical aspect that ensure your system's success. So let's discuss this pillar one by one. Reliability. Reliability means making system working correctly even when fault occur. What is the meaning of reliability? Reliability means you can trust a system, right? So what are the points that will become inside this reliability tab? The first point is meeting expectation. Meeting expectation means what you are expecting from the system will be able to deliver that, right? Take an example, let's say you ordered a pizza. So what you are expecting? You are expecting the pizza will come hot and with the right topping on top of that. So what is happening here? You are ordering something, you are expecting something, and you are getting delivered that. So your system will also be same. The system will be able to deliver what the user wants. The next point is tolerance of mistake. Reliability is like forgiving a wrong turn and still reaching your destination. Let's take an example. Let's say in Google Maps somehow you are supposed to go left but you come straight. Then what map will do? Map will again fetch the path and it will redirect you to your destination, right? Your software should be able to handle this also. Mistake tolerance is another main important point under reliability. Now the third point is performance under load. So reliability on this point means software will not crash when everyone else is using it. Imagine a big highway. Cars keep flowing smoothly even during rush hours. Similarly, your software should able to handle many users without showing downtime. Now the last point under this reliability is security. Your system will be able to store your data securely. Imagine it's like a secure bank. Only authorized people have the access to it. In the same way, your software will also prevent unauthorized access. So these were the 4 points that comes under reliability. Meeting expectation, tolerance mistake, performance under load, security. Now the next point is scalability. Scalability means having strategies and keeping performance good when even load increase. Imagine you are making rice for 5 people, for your family. But somehow, if some of your guests come, then what will you do if you want to make more rice? So first thing you will do, you will take a bigger pot, then you will cook, let's say, rice for 10 people. But if, let's say, some occasion is happening, a lot of guests come, then will you be able to do this in this pot which can only cook for 10%? It is not possible, right? So what you will do it in batch. Let's say you are making rice for 50 people, then for 10 you will make one bowl and you will make rice. For next 10 you will make another bowl and you will make rice, and in this way in 10 bowl you will be making rice. Your requirement is increasing. At that time your first priority is you will increase the power of your machine, like you are increasing the size of your pot. But after a certain time you are dividing that in batch and you are adding more machine to it, you are adding more pot to it. So here the terms come vertical scaling. It's like making a rice in that big pot, like you are increasing the size of your machine to serve more request. So this is called vertical scaling. Now the next point comes is horizontal scaling. Horizontal scaling is like adding more machine to share the load. So I already have given you the example. So here you are increasing the number of machine or the number of port, and you are dividing your whole traffic in lot of machine. Like instead of one machine you will have, let's say, 5 machine running in parallel, and when a lot of user is requesting, you have a load balancer who will be balance the load among these 5 machine, and those load balancer will request each and every machine as per their capability. So it's like distributing your whole traffic into more number of machine. Now the last point come under the scalability is load balancing. Load balancing ensures that your system will be able to handle the load of your huge traffic and distribute this among all other machines. You can think it like a traffic management. In a busy highway, what traffic police do? They basically stop a route and open a route, and again stop that particular route and open the reverse route, right? So in this same way, what load balancer will do, you have 5 machines, 10 machines, and there is a central load balancer. When some traffic is coming, some request is coming, first it will hit the load balancer, and load balancer will redirect that request to a particular machine, and in this way the load will be balanced among all the 10 machines, or maybe as per your requirement there can be 50 machines, right? Now the last point among these 3 pillars is maintainability. Maintainability means making life easier for the next software engineer who will be working on that project, and also for the operation people. There are also a couple of points that we can discuss under this maintainability tab. The first point is abstraction and making things simple. Let's take an example about abstraction. What is abstraction? Let's say you are making some dishes. So at that time you are adding the spices one by one. Salt, sugar, chili powder. These things you are adding one by one. But for a new developer, for a new person who is cooking for the first time, it's hard to guess that how much amount of salt I will keep or how much amount of sugar I will be adding, right? So as a solution, what you can do? So you can do that, mix all the spices in a particular format, and then when a new person will be cooking that food, they will be able to take that and put it into the dish, right? So here, instead of guessing each and every different kind of spices, the new developer will only be guessing final amount that he or she is adding into the dishes. So that is called abstraction. Abstraction is setting some rule. On top of that, the new developer will be working. So this abstraction will make your system simple and reduce the amount of error that can occur for human error. Now the next point is adaptability and flexibility. Let's take an example first. Think of a smartphone app that adjusts its layout when you switch from portrait to landscape mode. It adapts seamlessly, ensuring a smooth user experience. Maintainability is like having a wardrobe with mix and match outfit. Now the last point that comes under maintainability is health monitoring. Picture a doctor checking your vital sign. They monitor your health to catch issue earlier. Similarly, software needs effective way to monitor what's going wrong with the system, is there anything breaking or not, and this kind of stuff. When some user is using your software in the production level, then it's your responsibility that all the time you will check the logs, that is everything working fine or not, is there anything breaking or not. Maintainability ensure your software stay healthy. It's like having regular health checkup for your code. So these were a couple of points that you need to remember in order to be a good developer and develop a good data-driven system. So these 3 points are like the leg of tripod, and expect one point, this tripod will not be usable anymore. So when you are building system, remember all these 3 points, which are reliability, scalability and maintainability, and these are the building blocks of your system. So build them correctly.